Good morning. My name is Dave Pawson. I came from New Zealand to this museum at the dawn of time in 1964, and I was given a manual typewriter and a magnifying glass and told to get to work. I'm a senior scientist in the Department of Invertebrate Zoology in this museum. My wife, Doris, is a co-conspirator in much of this work that I'm going to describe this morning. We study marine animals called echinoderms, spiny-skinned animals, a group that includes the iconic starfish, sea urchins, sea cucumbers, etc. They are present in enormous numbers in the deep sea. And for example, sea cucumbers can comprise more than 95% of the total weight of animals on the deep sea floor in vast areas of the abyssal zone. They are of great ecological importance, and they respond dramatically to even slight environmental changes in temperature or increased acidity or in seasonal fluxes of available food. We're trying to better understand the role of these animals in the general economy of the deep sea. I'd like to very briefly describe three current projects called Faith, Hope, and Charity. Faith is that sea urchin's belief that perhaps the covering reaction in the deep sea sea urchin does some good. Many shallow water sea urchin species cover themselves with debris, as shown here. And experimental work over many years have shown that this so-called covering reaction can perform a variety of functions, reducing incident light, especially ultraviolet light, that sort of can penetrate the skeleton of the animal, to provide some stability when the water becomes more turbulent, for hoarding food, and there are probably a dozen reasons why these animals seem to cover themselves in shallow water. When you get into deep water, the covering reaction is almost never observed, and we've used many submersible dives to study these animals in the deep sea. But there's one species that lives down in the Caribbean, this one here called Conolampus sigsbeei. It lives in total darkness, and yet it is almost always covered. So they cover themselves, certainly not because of the incident light. It's certainly not a good form of camouflage, as you can see. It's not because you can see the animals. It's not a good way of food hoarding either, because they cover themselves with debris that is not used as food. And there's very little turbulence around in the deep sea, and so they don't gain any stability by doing this. Some authors have suggested for some shallow water species that the picking up of debris and accumulation of it is merely a tactile reflex on the part of these animals. They touch the debris and they pick it up with their adhesive little tube feet and pile it up. We've performed laboratory experiments in Curacao on these animals that we've collected live and brought back to the laboratory, and we've had no support for this notion based on what we've found. We're going to go back and keep trying that. Hope is that turtle grass will continue to be an important food source in the Western Atlantic deep sea. Turtle grass beds are very common around Florida, for example, and in the Gulf of Mexico coast. Turtle grass is a coarse grass that grows in shallow water from a depth sort of knee-deep water down to about 30 feet. And with wave action, pieces of turtle grass break off, they float out to sea, and they eventually become waterlogged and sink to the floor. In the deep sea, turtle grass can be everywhere. Here's a picture I took many years ago in the Bahamas at a depth of more than 3,000 meters, and those little dark objects there are pieces of turtle grass lying around. As food can be scarce in the deep sea, it's not surprising that a lot of deep sea animals eat this turtle grass. For example, the sea urchin, which is present in enormous numbers at great depths, eats turtle grass. But what amazed us when we collected one or two of them and looked in their intestines, we found that their intestines were filled with essentially nothing but turtle grass. And so turtle grass is a preferred food for these animals. That amazed us, and it sort of terrified us too, because experts have estimated that over the past 30 years or so, the area of turtle grass beds around Florida and the Gulf of Mexico has diminished by about 70%, due to human activities, construction, but mostly runoff of fertilizers and so forth from land into the shallow waters. So the available food for these animals has decreased by about 70%. And we wonder what they're doing now to compensate for that loss. And finally, charity. About 40 years ago, I published a picture there on the top left showing some sea urchins accumulated together and suggested that this might help them in reproducing because these animals release their eggs and sperms into the water. This was proved by Craig Young and a co-author in the bottom left. They found that males and females were gathered together there, and they could prove that this was to aid in reproduction rather than feeding. And the most recent picture we have of this is on the right, showing a bunch of animals, and they're breeding, not feeding. If they were feeding, their mouths would all be turned down, and half of these animals have their mouths turned up, which is fine for breeding, but not for feeding. And so Doris and I, having dealt with faith, hope, and charity, we're now moving on to the 7 deadly sins, and we're starting with gluttony and sloth. Thank you. Any questions? Thanks very much. Oh, sorry.
How do you take these pictures by scuba diving?
Yeah, all of these pictures were taken by almost all of them, from manned submersibles. And we've made hundreds of dives now over the years. And some of them were made by remotely operated vehicles that were unmanned, called ROVs. And these can do almost as much as a manned submersible, except you don't have the thrill of being down there and seeing the animals. But they're taking over from manned vehicles these days. Yeah. Yeah, the question was, why are these animals so brilliantly colored? And the answer is, I don't know. That's my answer. I really don't know. Some of these animals are absolutely gorgeous, and their colors are never seen, except by us, fortunately. Thank you.